Hello and welcome to this demonstration and discussion of Excel with space-based architecture. Excel is a widely used solution across many business verticals. Oil and energy research, capital markets, and many other businesses rely on the information provided by Excel spreadsheets to make critical business decisions. Unfortunately, power users of Excel are finding that it doesn't always scale to meet their modern needs. In this information overloaded time, they're finding the sheer volume of data they have to process doesn't often fit within a single spreadsheet. In addition, the number and type of calculations they're performing are too great for a single desktop or server to calculate in a reasonable amount of time. What these users need is a system that provides them with better uptime, more resiliency, so if a cat walks across the keyboard in the middle of a calculation, they don't lose all their state. In addition, they want a solution that performs better, they get results back faster, and can do all this while leveraging modern data center technologies like commodity hardware. This sort of grid-based solution is one that modern users are looking to find, and Microsoft and GigaSpaces are providing the solution. This solution harnesses the power of your data center to scale your Excel-based applications. It was jointly created by Microsoft and GigaSpaces, so it works with familiar versions of Excel and the other services that you've grown familiar with from Microsoft. This is a two-phase solution. First of all, take the data out of the spreadsheet and store it reliably in your data center. This allows you to address much larger data sets, terabytes if necessary. Once it's there, it can now be addressed by multiple users, running multiple instances of Excel. The second phase is to take the logic out of Excel and run it in parallel in your data center, harnessing the power of your data center to perform those complex calculations. These calculations and the information you're processing are all being held within the GigaSpaces Extreme Application Platform, and it's utilizing the space clustering technology. A space holds information in a reliable fashion in memory, scaling out across commodity hardware, using partitioning to spread the load, and replication to maintain reliability. The proxy is used by Excel and other clients so that it doesn't have to know about the complex topology of the actual physical space. This space-based architecture is a service-oriented architecture, one that leverages our service containers to allow you to dynamically deploy services on the fly, adding capabilities to your system and allowing it to scale when needed, utilizing additional compute resources as you add them to your data center. I'm going to demonstrate for you an Excel spreadsheet that leverages the power of the GigaSpaces Extreme Application Platform. You can see in this diagram how Excel, utilizing familiar technologies such as user-defined functions and RTDs, can access information through the proxy. In that way, the real topology does not need to be known by an Excel user. As far as they know, they're running something on their local desktop. Under the covers, of course, they might be addressing hundreds of machines, so that their work is being performed extremely quickly. Okay, there's nothing like a demo to prove that what I'm saying is true. Let's open up a spreadsheet here. On my desktop, you can see that this spreadsheet is getting updated with information. What you don't know is it's talking through an RTD to a proxy that's being informed of changes to the various stocks that are within this portfolio. And those changes are all happening on the grid inside of the GigaSpaces platform. Here we're going to invoke a method. This user-defined function will also invoke logic within that grid. Here we're going to get the maximum price of all stocks. As I click enter, you'll see the results come back, and we know now that the symbol IHI has the highest price of all stocks. That server-side logic is now revealed within my spreadsheet as part of my view as I add it to my portfolio here. Now the question is, what happens if this spreadsheet were to crash? If I were to just kill it like this? Well, you'll notice first of all that I'm running another spreadsheet behind, and then it continues to get information from the grid. But did we lose the information that was in that spreadsheet? Let's restart it. Here it is again. Notice the new row that we created is gone. but the rest is still there because that was the save state of this view. But don't worry, invoking that user-defined function again will retrieve that same result, assuming it's the same high-priced stock, and we can add it back into our view again, like this, and continue working. We didn't lose the business information that we need. We only lost a view when we closed our spreadsheet. Here's a view of the user interface to the GigaSpaces platform. Here you can see we actually have 4 spaces running, 2 sets of primary partitions, and their backups. There's primary 2, and before we were looking at primary 1. Green lights mean good, and in this view, green means primary. So these are the 2 primary spaces. They're actively updating information and processing requests, such as that user-defined function that we executed earlier. You can see tens of thousands of operations have occurred while I've been talking to you. This rich platform allows us to serve up not only Excel, but many other types of application solutions as well, allowing for interoperability. Now what would happen if we were to kill off this particular primary space? Well, by opening up this console, I can see it's running right here in this process. It's the stock space container 1. That's one of our primary partitions. If I kill it, what will happen? You'd expect that it would be a bad thing. Watch how it self-heals, and watch later to see that Excel doesn't break. So you notice I just killed it off. You see there's only 3 green lights. Watch as it self-heals. And there it's back. So now we have 4 green lights, 4 spaces. How did that happen? These services are managed by an intelligent framework that detect the failure, locate a suitable host, and reinitiate the same logic. So we have 4 spaces again. But even faster than that respawning of the space, the backup took over the primary's duties. You'll notice that the 2 green P symbols are now associated with one different container. Instead of it being the container 1, it's the container 1_1. That's now a primary, because it immediately detected the failure of its primary and took over its duties. And of course, the spreadsheet in the background never knew that anything went wrong, because it was utilizing the proxy, which hid not only the topology and complexity of our large infrastructure from the spreadsheet, but also the awareness of any failures. Well, I hope that this demonstration has been entertaining and encourages you to try the solution out in your own environment.